Welcome to NALLA NARASIMHA Reddy Education Society's group of institutions, integrated campus, Hyderabad, structural engineering, 1 reinforced cement concrete. I am Dr. A. Mahesh Babu, Professor, Department of Civil Engineering. In previous videos, I explained about different types of structures, and here we'll see precast concrete. You know what is the precast? See, this is we construct by providing formwork. We will pour concrete into the work and will remove. It is called as cast in situ construction. If concrete elements are cast in factories or elsewhere, we have to transport them into their final destination. These are called precast element. That is precast. Before at the site when we are constructing different types of structural elements, we construct at the site by different technologies, and we'll transport from the different factories and elsewhere. We transport to the at construction site. These are called precast concrete structures. What are the uses? Generally, these are very useful. Only thing is the transportation cost is more. As you know, what is the unit weight of RCC? 25 kilonewton per meter cube. So for 1 cubic meter, 25 kilonewtons. It's very, very heavy. So the transportation is only problem for, but small structural elements, it's not a problem, like pipes, that like manhole cover. These are very maybe you can transport easily. See, so these are precast structures are very useful, and in the following areas we will use pipes and tanks, poles, electrical poles. You see piles, okay, in the construction field, foundation piles, sleepers is very very important, and many entrepreneurs, they are doing this one, this sleepers, okay. The sleepers, what is sleepers in railway, sleepers, this is our precast members. We'll catch somewhere and we'll transport to the site. Okay, so sleepers, this is one of the um, um, this advantage and very useful in precast member element. Okay, in pavement, we will use in pavements also. Okay, where we required an urgency. Suppose traffic conditions are heavy, you are unable to do the construct, because at the site, if you want construct, it will take more time. If you precast members, if you construct with precast member, the cost of and the time is very less at the site, so you can avoid the traffic problems. Okay, you may not have this place to work there. There will have pavements, lintel beams. See, on the above the lintels, windows will have lintel beams. Okay, see, small sizes, beams and girders, these are big one. So these transportation somewhat difficult. We have to use big cranes, and this is only um, the cost is increases in only transportation and building blocks, different type of blocks, walls, panels, slabs, and different types of. You can also precast column, beams, and all different type of blocks. You can construct it in the other industry or other factory, and under this provision, and can construct these buildings. Wall panels, as I said, wall panels, manhole covers. Seen generally in sanitary, you will see manhole covers. These are all advantages of the precast structure. And this is once precast structure, how this is a pre-tension, pre-stressed concrete structure. So this is a like a pavement pre-stressed, okay, like this, or any like girder after formwork hardening. This is will undergo pre-stressed, okay. And then we'll cut this one. We'll see next video. See, and these are with the help of equipment, we induce tension in the structure, right? Observe, this is observe carefully. See here, if you see here, this is a concrete member, right? This is a concrete member, okay. We are steel provided a job. This is an abutment and steel lender, and after casting, we will have this pre-tension and undergo tension, casting of concrete. See, this is after tension will pour the concrete in the formwork. Okay, in this way we cast. Just this basic concept of pre-stressed concrete members, how to construct. This is for only example. See, the designs are different. This is say for a pavement or small work. Okay, so this is one of the member. See here already tension in implemented in this reinforcement, and then see structure will be like this. This is pre-stressed, right? This is pre-stressed. Now this is will be like this, okay, right? See, if you observe, this is pre-tension. These are the stages, different stages of stressing. And next one is this is already has we have observed. If your vehicle moving like this on a bridge, it will be like this. But the cracks will be developed like this if you don't have reinforcement. In the middle, we have pre-stressed tension reinforcement. That's why you won't. There will not be any crack and deflection in this element. So this will way smoothly you can move. This is one of the advantages of the structure. Okay, these are all precast. See, in this generally in urban areas, it's difficult to transport material and see construct at the site. So then we'll use this type of precast structures. Okay, just we'll see some small video, and you observe carefully. Types of concrete.
Pre-stressed concrete. In case of big concrete construction projects like bridges, steel reinforcement bars alone won't be sufficient to provide the necessary tensile strength. In this case, pre-stressed concrete is being used. In pre-stressing, the rods or tendons are stretched along the axis and cement is poured.
See, observe this figure, how they are constructing pre-stressed reinforced
Later,
concrete.
when the tendons are released, the compression is generated at the bottom, which tries to counter.
See how generated, how the concept in this structure. See, repeatedly you observe this video 2 or 3 times, you will understand simple what is pre-stressed structure.
balance the compression due to loading at the top part of the beam. The principle behind pre-stressed concrete is that compressive stresses induced by the high-strength steel tendons in a concrete member before loads are applied. This will balance the stresses imposed in the member during the service. Pre-stressed concrete can be used for the construction of roofs, floors, walls, and bridges with longer unsupported spans. Pre-stressing is generally done by two methods: pre-tensioned concrete and post-tensioned concrete. Pre-tensioned concrete. Pre-tensioned concrete is those in which the tendons are tensioned before pouring of concrete. The tendons are initially tensioned and anchored at both ends, and then concrete is poured over it and cured. When the concrete attains desired strength, the tendons are released and projections are cut out. The pre-stress imparts into beam through bond action. Post-tensioned concrete. In post-tensioned concrete, the tendons are tensioned after the concrete is poured. Initially, the concrete is cast around the sheathing. The ducts are formed in concrete in which tendons are placed. After the concrete is hardened, the tendons are tensioned by hydraulic jacks and anchored. In case of bonded type tendons, the duct is grouted with sufficient slurry. In the unbounded type of tendons, grouting is not necessary. We will learn about this later. Thank you for watching. Stay tuned. The best is yet to come.
See, watch this video 2 or 3 times. You will understand the concept of pre-stressed and post-tension concrete structures. And we'll see other structures in next class. Thank you.